Systems of linear inequalities. All right, so today we're going to determine whether an ordered pair is a solution of a system of a linear inequality. We're going to graph systems of linear inequalities. We're going to write systems of linear inequalities from a graph, and we're going to solve real-life problems using systems of linear inequalities. All right, take a look at some vocab that you need to know. A system of linear inequalities is a set of two or more linear inequalities in the same variables. An example is shown. A solution of a system of linear inequalities in two variables is an ordered pair that is a solution of each inequality in a system. All right, so remember we've already solved systems of equations, which was two or more linear equations. So the same thing, except now we're dealing with inequalities, less than or greater than. All right, so a solution of a system, again, if you take an ordered pair and you plug it into both inequalities in the system and it makes a true statement, then that would be considered a solution of the system of linear inequalities. The graph of a system of a linear inequality is the graph of all the solutions of the system. All right, so here's an example that you can see below. All right, example 1. Tell whether each ordered pair is a solution of the system of linear inequalities. All right, so we have y less than 2x and y greater than or equal to x plus 1. The first one, 3, 5. So this 3 is our x, 5 is our y. We have to plug it into each inequality and see if it makes a true statement. If it does, then the ordered pair is a solution. So for 3, 5, 5 is the y, so we're going to say is 5 less than 2 times x, which is 3. Is 5 less than 6? The answer to that is yes. All right, let's look at the second inequality as well. So y greater than or equal to. So y is 5. Is 5 greater than or equal to? X is 3. 3 plus 1 is 5 greater than or equal to 3 plus 1 is 4. Is 5 greater than or equal to 4? Yes. So because that is true for both inequalities, yes, this is a solution. All right, let's check B part. -2, 0. Again, -2 is our x, 0 is our y. So we're going to start out with 0 is 0 less than 2 times x. X is -2. So is 0 less than -4? The answer to that is no. 0 is actually greater than -4. 0 is greater than all the negative numbers. So this one is not true. So this one is no. So this one is not a solution. So we know this ordered pair is not a solution to the system because it makes the first inequality a false statement. But we can still check to see if this is a solution to the second inequality. So is 0 greater than or equal to x is -2 plus 1? So 0 greater than or equal to -2 plus 1 is -1. Is 0 greater than or equal to -1? The answer to that is yes. So -2, 0 is not a solution to the first inequality, but it is a solution to the second inequality. But it makes it not a solution to the system if it makes either one of these no. So that's why we could go ahead and answer the question even after the first inequality, checking the first inequality before we checked the second one. Self-assessment. All right, I want you guys to look at these questions and then see if you can answer these on your own. So number 1, how many linear inequalities are in a system of linear inequalities? Number 2, how can you verify that an ordered pair is a solution of a system of linear inequalities? Number 3, tell whether the ordered pair is a solution of the system of linear inequalities. This is like what we just did in example 1. And open-ended, one inequality in a system is this. Write another possible inequality in a system so that -2, 6 is a solution of the system. Open-ended means there are infinitely many correct answers. You just have to meet the criteria that this is going to be a solution of the system. All right, so when you answer these, come back and we will check your answers. All right, hopefully you took time to do these. Let's see how you did. How many linear inequalities are in a system of linear inequalities? The answer to that would be 2 or more. How can you verify that an ordered pair is a solution of a system? Substitute the values into both inequalities and verify that both inequalities are true. Tell whether the ordered pair is a solution of the system. The answer is no. This one's very easy to check. The first inequality is y less than 5. This is 5. Is 5 less than 5? No, it's equal to. So if this were less than or equal to, that would be true. So the answer is no. You don't even have to check the second one because, again, if it says, is it a solution to the system, it has to make both of them true. So the fact that the first one is false, you can go ahead and conclude that it's not a solution to the system. All right, number 4, open-ended. One inequality in a system is y greater than or equal to 2x plus 3. Write another possible inequality in the system so that -2, 6 is a solution. Here's a sample answer. Hopefully you have a different answer, but 6 would be my y. So is 6 greater than 3 times -2? 3 times -2 is -6. -6 minus 2 is -8. Is 6 greater than -8? It is. So that would be an example of one solution. Again, open-ended means there are infinitely many solutions to that question. Graphing a system of linear inequalities. All right, example 2. This says graph the system, identify a solution. All right, so y less than or equal to 3. All right, so we're going to come up 1, 2, 3, and we're going to draw a line across through here. Now, less than or equal to means it's going to be a solid line. So up 1, 2, 3. So we're going to have a solid line, and we want everything less than or equal to this line. So I'm just going to draw an arrow now. Some teachers go ahead and shade and then double shade. I don't really like that method because it's still a little confusing on where your solution is. I like to just put arrows to indicate which direction your solution is going to be shaded for this one. And then we'll do the same thing for the next one, and then only shade the actual solution area. All right, so the next one says y greater than x plus 2. So let's use a different color for this one. So we're going to have a y-intercept at 2, and we have a slope of 1. All right, so I can go in both directions here with a slope of 1. And then I can graph this line as well. Now you can see that this one is strictly greater than. So we're going to need a dotted line for the blue one. All right, let me change the color here. All right, so that's going to represent the second inequality, and this one we want to be greater than, so we're going to do above. Greater than means it's going above. All right, so what we need to do is find the solution of the system. The solution of the system is going to be the area that makes both inequalities true. So everything below the red line and above the blue line is going to be in our solution set. So it's going to be this area over here. And it's going to come right up to the blue line, but the blue line, the points on the blue line is not part of the solution. The red line is solid, so the red line will be part of the solution. Then it says identify a solution. So all you have to do is pick a point that falls in that shaded region. Let's choose a point, maybe let's come over -1, 2, 3. So that would be -3, 2. And then you would check it like we did in the previous one. So 2 is your y. Is 2 less than or equal to 3? Yes, it is. So it works for the first one. And then use the second one. 2 would be your y. So is 2 greater than -3 plus 2? What's -3 plus 2? -3 plus 2 is -1. Is 2 greater than -1? It is. So we have graphed the system and we have identified a solution. Again, everything in this shaded region here is a solution. We just identified one that's in that region so that we could check it. All right, example 3, graph the system. So this is in standard form. First thing we need to do is put it in slope-intercept form. So the first equation, I'm going to subtract 2y from both sides. So I'm going to have y less than -2x minus 1. So all I did was take the 2x and subtract it to bring it to the other side so that we have this in slope-intercept form, which is easy to graph. I'm going to do the same thing for the second one. So I'm going to have y greater than. Again, I'm going to subtract the 2x to the other side, and I'm going to have plus 3. Now, you should quickly identify that these have the same slope, which means same slope, different y-intercepts. These are going to be parallel lines. So let's see what that looks like on here. So the first one we'll use red. So we're going to have y less than -2x minus 1. So I'm going to have a dot here for -1, my y-intercept, and then my slope of -2 down 2 over 1. Also could rise 2 and go left 1, which is the same slope there. So let's use a dotted line because this is less than this. All right, I'm going to graph the second line as well. Let's graph it in blue. So I'm going to have a +3 as my y-intercept. And I'm going to have a slope of -2 down 2 over 1. And again, I can graph that with a dotted line. All right, now which way do I need to shade it? This one is y greater than. So I'm going to have greater than everything on the blue line. And for the red line, this is y less than. Less than would be going this direction. And the solution to the system would be everything that overlaps. So this one would have no solution. because there's no intersection for any of the points.